Hi everyone, this is Rajit, student in Electronics and Communication, VVIT number. Today I am going to present on asynchronous counters. Let's get started. Introduction. Okay. Asynchronous counters is also called as ripple counters. Okay, the another name for asynchronous counters is ripple counters. In these asynchronous counters, clock pulse is directly applied to the significant flip-flop. Okay. In this, the clock pulse or control input is applied to the LSB flip-flop. Okay. For the higher order flip-flop, the clock is the output of the previous flip-flops, either the complement or uncomplemented output. Okay. In these asynchronous counters, only fixed counting sequences are used. For example, there is no truncated and non-truncated in this. Only fixed counting sequences are there. Okay, counting can be designed for either up counting or down counting. Okay, there are two types of counters similar to the synchronous counters: up counting, down counting, and up down counting. Okay, in synchronous counters, we can design the counter by using any type of flip-flop. Okay, but in asynchronous counters, only two flip-flops are used because the asynchronous counters are used to operate in toggle state. So the flip-flops that I have that has toggle states are JK and T flip-flops. So only by using these two flip-flops we can design the asynchronous counters. And next, the number of flip-flops required for designing of these asynchronous counters is equal to this one. Mod value less than or equal to 2 per 1, where n equal to number of flip-flops. Okay, and the count value of this counter is called as mod value, similar to the synchronous counters. Okay, the counting style of synchronous counter depends on triggering method of the counter and output access the clock to the next higher order. That means to decide the asynchronous counter as a up counter or down counter, we have to consider type, two things. First one is what is the type of triggering given to the counter, and second one is what type of output, whether it is a complement output or uncomplemented output connected to the clock. Let us discuss about the types of counting based on the triggering and output given. If the triggering is positive edge triggering and the output connected to the clock is uncomplemented, then the counting style is down counting. Similarly, if the triggering is positive, clock is uncomplemented, then the counting style is up counting. Similarly, negative edge triggering and complemented uncomplemented output, counting style is up counting. Negative triggering and complemented output, down counting. Okay, now discuss about the one example of this asynchronous counter, how to design it, its working and truth table. First, let us discuss about 4-bit asynchronous counter. Here the circuit diagram or logic diagram of this asynchronous counter. Here the mod it is given that 4 bits, so we can use 4 flip-flops. Here we consider JK flip-flop. First, taking 4 JK flip-flops and name it as flip-flop 1, 2, 3, and 4. Okay. And the first in clock is given to the least significant bit. This is one. It is positive expected. And next, JK flip-flop and T flip-flop are operate when the inputs are high in toggle state. Okay. So we connected these inputs of this JK flip-flop are high. So this flip-flop is working in toggle state. Similarly, these all flip-flops inputs are connected to the high. That means logic one. Okay. Next, this one is considered as Q1A, Q2B, Q3C, and Q4D. Here the complemented output is connected to the clock to the next flip-flop. So this is positive triggering and complemented output is connected to the next flip-flop. So From the above, we can say this is an up counter because positive edge triggering and complemented output. Okay. This is the counter table for the 4-bit asynchronous counter. From the above operation, we can say this. And timing diagram of the 4-bit asynchronous counter. The first one is clock Q1, Q2, Q3, and Q4. Coming to the limitations of this 4-bit asynchronous counter and all synchronous counters, propagation delay issues, because the propagation delay of this asynchronous counters is very high, because the input of the next flip-flop is the output of the previous one. So the previous one propagation delay is added to the next one. So the overall propagation delay is the cumulative of the all flip-flops. Okay, each flip-flop wait for the previous one to toggle, causing cumulative delay. Okay, slow speed of operation. Due to the propagation delay build-up, the counter cannot work efficiently at high frequencies. That means at high clock frequencies, the asynchronous counter does not work effectively. Occurrences of glitches, temporary interconnect outputs appearing due to state transition. Okay, if one cycle is completed, for changing of the state from 15 to 0, there is some glitches happening at sometimes. Difficulty in decoding. Irregular output timing makes decoding specific state harder. Unsuitable for high-speed applications. Asynchronous counter become unreliable when used for faster complex digital systems. Okay, this asynchronous counter does not suitable for working at high-speed applications because of its propagation delay. Thank you.